Well, hello again. In this example, you will gain experience with identifying zero-force members within a truss and doing this just by observation. Let's take a look at this particular truss where we're being asked to identify all zero-force members. It may be helpful for you to recognize that we are going to have some reactions at these locations. Now, there's two basic rules that we're going to be trying to identify, and that is if two members come to a joint and they have no external force, and they are not collinear, then out of necessity, those must be zero-force members. You can also remember the rule that if you have three members coming to a joint, like at joint G, and if two of them are collinear and the third is not, and there is no external force there, out of necessity, that one must be zero force. Now the idea here is that once you've identified zero-force members, you want to mentally erase those members in your mind and go back and reevaluate, scan the entire truss for any of those conditions. So as I go to joint D, let's look at that first. I have two members coming to the joint and they aren't collinear, but they do have external forces that are applied there, and so out of necessity those are not zero-force members, or at least we can identify them as being zero-force members. And so in a like fashion, looking at joint A, I can identify that those aren't zero-force. But let's go ahead and look at joint H. If we look at joint H, we can identify that CH and GH are zero-force members. So mentally remove those, then go to joint G, and two members without an external load on it, we can identify that CG and FG are zero-force members. Now remove those in your mind and go to joint C, and we can identify that BC and FC are zero-force members. Then go to joint B, and what you'll find is you still have three members coming in there, and so we can't identify those as zero-force members. Now, as far as following the rules, that's the total number of zero-force members that we would have identified following that procedure. But you're going to notice that member EF I hadn't identified yet. It works out to be a zero-force member, and this is really the concept that we want to understand here, is that zero-force members are defined by whether or not there is an equal force or a force in that direction of the bar. And so I'm going to just sketch here just a little bit of a free body diagram for joint F. We know that we've got a force here in the form of a reaction. We've got a force here in the form of NBF. You'll notice that all other bars, bar FC and bar FG, those are zero, so those don't show up. And so the only other thing I have here is bar NEF. And so if that's my free body diagram, I know that out of necessity, when I sum forces in the x direction, that's going to have to be zero. So that's using just a little bit higher understanding of the overall concept. But nonetheless, you know, even without having to sketch that free body diagram, you should get to the point you should be able to identify bar EF as having been a zero force. So if you count that up, what you will find is you have 7 zero-force members. That concludes this example. As always, it's a beautiful day for studying structures.